And I'm going to switch cameras. The dog waits till the video starts recording to start screaming, of course, because that's how he rolls. All right, so where were we? Let's get onto our stats screen. Make those notes smaller. And I wanted to come back to something that we had talked about last week, but I want to bring it up again real quick. We're going to look at these shapes again, but that's not what it is. When we did this right here. So why is it not showing up this pen? So see below for midpoint info. I need to share a link to this so you guys can see my lecture notes. So what's today? Monday, January 31st?
Yes.
In the year 2022. So let's talk about midpoints. Stop that. Midpoints for bins and classes, because they will show up in the problems in the homework, and it's worth knowing about them. So recall, we had bins for ages. Let me change up colors. Let's go with pink. We had 10 to 19.99, and then we had 20 to 29.99 and 30 to 39.99. So these were our bins or classes. The best and easiest way to calculate midpoints, to calculate the midpoint for a bin. Is that the biggest? Okay, Gabe, I can pause a second. I mean, there is only, what, 4 of us? 4 that aren't me. Can anyone else hear me? I didn't even think to ask that.
Yeah.
No one has responded
Yes.
vocally yet, so.
Yeah.
You guys, oh, I have, oh, shit, I have you guys muted. Say something again. It looked like your mics came on.
Yes, we can hear you.
Yeah.
Yes.
That is
Okay,
weird.
awesome. I'm like, why can't I hear you guys? I'm like, nope, don't need to hear you. I'm gonna just mute y'all. Give Gabe a second to get back. Today's lesson should be shorter. I have a meeting at 2:30, and in all reality, before I found out I had a meeting at not 2:30, 3:30. In all reality, before I found out I had a meeting at 3:30, I knew this was probably going to be done before 3:30.
Hey, I have a question.
Yeah.
For the MyLab, the Pearson thing, you know how it says optional for like 1.1, 1.2, 1.3. Do we have to do those?
Nope. That's what makes them optional.
Okay, because I was seeing right there that it said it was out of like so many points. So I just didn't want
Yeah,
to like, skip
those
up
ones are not even
your
added
thought.
into the points.
Oh, okay.
Even if you do them, they're not contributing to your score.
Okay. Thank you.
And I would only really do them if you've gone through the homework and you're getting stuck on something and you're like doing it at 1 in the morning, so you can't email me and ask questions and you really want to know right away, you know, because some of them are good and some of them are not. They'll like do something by hand that you wouldn't do by hand. I'm sure many of you have by now got to the whole, let's pick a random number using a table and they're going to give you a row and a column. They start at this weird spot and it's really hard to interpret what's going on. It's terrible. No one would pick random numbers that way. Ever.
Yeah, I've taken intro to stats before, but I didn't really like the professor, so I kind of dropped it. But yeah, the whole Pearson thing was kind of pain in the ass because of the you have to be like really specific.
Yeah, it can be really specific and it's got a lot of questions, but it's one of the better ones for homework that will give you feedback right away. And your final is not in it. We're only going to have homework up through there in there. And then the final is going to be on Canvas because, yeah, it's going to give the final. I want to be about statistics and not StatCrunch. So,
Okay. Yeah, because I did an exam on there or a quiz. I'm not too sure, and I got a really bad score because of how you have to be like really specific on your answer. So
I don't even know that I had quizzes in there.
I don't know the other professor that I had.
Okay, yeah.
Yeah,
you got to check your rounding and make sure you do the right number of decimal places. It's a lot of fun.
Yeah, and then I had actually another software was kind of similar to that. I'm not too sure if it was that one, but it was for chemistry, and that one was really difficult to use.
Right. I have not done chemistry online, so I don't know about those, but I'm sure that it's got some of the same problems. If you don't do the notation correctly, it says it's wrong. Like if you did CH6 rather than CH and then 6 down below.
Yeah, that was
That kind of
hard
shit.
part.
Yeah.
Because it was the year where we transitioned to online. So we went from being in a lab every Tuesday and Thursday, to being in class, and I don't know, it was just difficult.
Yeah, and believe it or not, it was difficult for everyone. Even that, like a lot of us were not ready. I've never taught online. Many of us have not taught online. And I'm betting none of the science teachers have done it because you're right, chemistry is not meant for online stuff.
Yeah, I had El Bogonco.
Okay.
And yeah, he didn't know how to move away and move around the whole internet stuff. He even said it.
Right.
Yeah, so
Now,
it was
hopefully most of the teachers were at least semi-competent in general internet skills. That isn't a given.
No,
Some
I think
teachers
he
that
had
are
his
really old suck at computers.
I think he had a TA to help him out, but even then it was kind of difficult for him.
Wow. I wonder what Gabe's doing. All right, well, I'm going to start up. It's been a little while for Gabe, and he's still not back yet. Okay, so midpoints. To calculate the midpoints, what you want to do is add the lower limit for your group. The next lower limit should say and the next lower limit. Not limit. That's next lower class number. Let me change that. Has some calculus terminology. This, like, it works, but yeah, it was lower. We said lower class limits before. Lower class limit. And next lower class limit. Then divide by 2. So I could say like L1 plus L2 and then divide by 2. Generally in a calculator, you want to hit enter first. If you don't hit enter, you're going to fuck it up. Or if you have parentheses, that works as well. So in this scenario we've got here, I've got for the 10 to 1999 group, I'm going to take the 10 and I'm going to add the next group, which is 20, divided by 2. And 10 plus 20 is 30 divided by 2. That's 15. So the midpoint would be 15. Exactly, 15.00. If you do it in a calculator, you want to do 10 plus 20, then do the equal sign. And then, I guess those are like keys. And then sometimes a lot of calculators, you can just keep going. And then, or some of them you actually like have to hit the answer key and then divide by 2. And then the equal key again. That's like calculator work right there. If you have a parentheses key, that works as well. Parentheses 10 plus 20 end parentheses divided by 2 equal sign, and that works also. All right, so Gabe just popped in. He's connecting the audio real quick. I'll say it again for him real quick. As soon as it says he's connected. Still connecting. Bueller. All right, Gabe, can you hear me? Can you hear me? Do you have your computer muted or your like headphones plugged in or something? He might still have sound issues. All right, so let's take a look at chapter 3. Or not chapter 3, 2.3. My dog is acting up. My wife knew I was starting lectures right now, and what does she do? She leaves the house 3 minutes before lectures start, knowing the dog is going to act like this. She said, F your class. That's what she said. All right, so 2.3 is on other ways to do graphs. Let me go tell him he's okay. 1 second. All right, my wife just walked in, so she shouldn't do that again. All right, so some graphs we're going to look at. We're gonna look at the stem and leaf plot. Okay, let's say we had some data. Wow. Let's say our data had these numbers. It had 10, 10, 11, 12, 14, 14, 14, and 17. Oh, and maybe we should add a couple more numbers. Let's go in the 20 range, 20, 22, 22. Then we'll jump up to 33, 34, 38, 38. That's a good range of numbers right there. So the way the stem and leaf plot works is it focuses on separating taking the numbers apart. It's easy to notice on the 2-digit number, the way it works, it just chops them up. The numbers all start with a 1, 2, or 3. So the way the stem works is the stem is the first numbers. 1, 2, and 3. And then the way the leaves work, like a plant, is you just write the numbers that are there that follow the number of the data, and you don't put like commas between them. So like 1, 0 represents the first 10. Then I'm going to put another 0 for the second 10. And then I can change colors real quick. The 11 gives me a 1 right there. The 12 gives me a 2 right there. Back to pink. We've got 3 14, so I'll put 3 4s. And that represents those like that. So that's what ends up happening. And I'm going to just finish out this table real quick. I'm going to stop changing colors. For the 20, I have a 0, a 2, and a 2. And for the 30s, I've got a 3, a 4, 34, 38, and 38. And I'm going to actually expand that a little bit. Erase remark. Let's make that right a little bit better because it's helpful to see it lined up. And I've got sloppy. 4, 8, 8. So the pros of the stem and leaf plot. Stem and leaf plots retain all the data of the data set. Welcome, Ariel. Stem and leaf plots retain all of the data of the data sets and still show the shape of what it looks like. Although it's sideways, it's up and down. I'm not going to have you do one of these because let's face it, see how long it took me to do that, and I only had maybe 15 numbers, and it takes a while to do. The biggest drawbacks of the stem and leaf plot are it sucks for big data sets. I see someone commented in chat. Let me read real quick. It's okay, Ariel. But it keeps all the data, which is nice. Like even with continuous data. So you can have it show to a lot of decimal places fairly well. It just gets ugly. It's not used that often. It's not used often. There's another one that we can do, like frequency polygons. And again, I'm not going to have you do it in this class, but I'm going to show you how to do it in case you want to know. Whoops. So frequency polygons. These use the midpoint. Bins or classes or regions. And it's on summarized data. Summary data. Like frequency tables. Okay. The stem and leaf plot, I'm going to write down how you get to them in StatCrunch before we do it. So the stem and leaf plot. And I don't even think I assigned some homework on this. I don't think you have homework on either of these. In StatCrunch, you want to go graphs. And I believe it actually says stem and leaf. And then when we do frequency polygons, which has a weird name for what it is really just a line graph. Here you go in StatCrunch, you're going to go graphs, scatter plot. But you need the data in the table as a summary. Summarized. And in the table. And I'll show you both of them. We're going to do all this stuff in StatCrunch real quick. We're going to do it for the age group. So I'll give you a second to finish writing that. Okay, let me share screen. Anyone need that up longer? All right, let's share screen then. And we'll come over to StatCrunch. I had already opened up my Stat Lab. I clicked on StatCrunch and it opened up that window. And I just opened the data set that we were looking at before. Move that bar out of the way. So let me just show you the stem and leaf plot on age. Graph, stem and leaf. I'll click on age. You tend to go with leaf unit and let it go as it is. And we can see the data set here. In fact, notice it has broken up all of them into two sets. Like one covers these two covers these, 3 covers these, 4 is these two. I add them all the ones on one line. This is how they end up dealing with it when you have too many entries for a starting thing. This says I've got one 14-year-old, the 1 and the 4 makes a 14. And then I've got 2 5s, which means 2 15s, 2 15-year-olds, 3 6s. So I have 3 16-year-olds. And down the list, and they often break it up into 0 to, if the list is too long, they do 0s and 4s, 0 to 4 on one line, 5 to 9s on the next line. This one is set up to show an outlier. We haven't discussed outliers yet, but we will on Wednesday. But a quick just basics of the outlier is it's a data point that's far outside the rest. Kind of like if we were talking about income and Elon Musk was in the room. He would make all the data results skewed way off because he makes way more. So that's kind of how the stem and leaf plot works. Frequency polygons. I'm just gonna, okay, move that out of the way. So the frequency polygon, I'm gonna do a table real quick. Where's my table? Stats, tables. I'm gonna do frequency, and I'm gonna do it on the ages. And I'm just gonna do frequency, not relative frequency. And I'm gonna store it in the data table because that's kind of how it needs to be done. And I'm not gonna bin it yet. I'm gonna show you what happens with the frequency polygons if you don't bin it versus binning it. So I have 183 entries and it's got all the ages here. And like there was, for an 18-year-old, there was 24 entries. So I'm gonna say, I'll call this age 2. I'm gonna call this frequency 2 so that when I'm looking for it, when I try to do the scatter plot, shows up. I can go graph and then scatter plot. We're gonna end up using scatter plot a lot this semester, but not so much in the beginning. For frequency polygons or these line graphs, the categories are what go in the first variable. X is gonna be our age, and Y variable will be the frequency. And rather than doing midpoints, I'm just going to leave it as it is, but I'm going to select points and lines, holding down the control key while I click lines so both show up. And if I just click compute, we can kind of see what it looks like. So for each number, it shows the peak, how many there is. So it's one way of looking at it. It's kind of, it isn't used that much when it's an individual data set like I had it. But we can also do that same table, and I'm going to bin them. And I'm going to start at 0, and I'm going to do a width of 10 for the age. And we looked at binning before when we did this. And I'm going to store it in the data table. Okay. So the first thing I'm going to do is when you do these things in, like when you're doing them, you want to have a 0 as the first frequency. So you want to do the group before the group you have. So I'm going to just kind of like copy, age was the title row. I'm just going to copy this down and move it down here. I'm going to call this 0 to 10. And it has a 0. And then I'm going to put 80 to 90. And that has a 0. You want a 0 before it and after it. And now I don't want age. I'm going to do the midpoints. And I'm going to call this frequency 3. Midpoints is you go halfway between the two lower classes, like we just got done talking about. So between 0 and 10, add up 0, add up 10, adds a total of 10. 10 divided by 2 is 5. I will call this 5. That's halfway between 0 and 10. The midpoint for the 10 to 20 range, we're going to add the 10. Thankfully, the way the binning does it, it shows me both numbers there. I can just add those two up. 10 plus 20 is 30. Divided by 2 is 15. 20 to 30, we add those up. 20 plus 30 is 50. 50 divided by 2 is 25. 30 to 40, add those together is 70. 70 divided by 2 is 35. And you'll notice a trend. It has a 5 at the end each time, and the tens digit just keeps going up. So I can, rather than spelling it out each time, I can do that. And then when you do the scatter plot, you go graph, scatter plot. I want to use midpoints. I want to use frequency 3. I am going to display both points and lines. And I click compute. And now it shows it. Why is that backtracking? That says 66. I should say 55. Option, edit, let me recompute. There we go. So like this is 0, this is 20. 20 is up here. 10 is like right here. So this is 15. And it's doing that, it's doing the midpoints. So these are called frequency polygons. Again, I think it's kind of lame. This one does kind of help show the shape of the graph though. Notice that the numbers on the left are really tall. And then as we go to the right, it gets really long. So this is kind of like what we were doing with the shapes that we did the other day. And I want to actually go back and talk about that a little bit more. Because I don't know that I gave you some examples of what they look like. That's it for like the StatCrunch bit. So let me go to the other handwritten spot. So the shapes or distributions is the next category. Shapes or distributions. And we talked about at least 3 of them. I know we did the bell shape and we did the skewed left and the skewed right. There's one more. I don't know if I talked about the uniform distribution. So I'm going to do that now. Like if you've got a die, which is singular for dice. And there's 6 sides, so 6-sided dice. Or if you're a gamer, it's called a D6. There's 6 outcomes, and let's say I rolled it 1,000 times. No, let's say I rolled it 6,000 times. I can do the numbers easier that way. Say I rolled it 6,000 times. And I came up with the following graph for it. So this will be my 1, this will be my 2, this will be my 3, 4, 5, 6. So let's say the 2 had a little bit more. The 3 was a little bit lower. 4 was like a little bit higher than that. 5 was up here. And 6 was down here. And maybe this was a little over 1,000, like 1,005. Maybe this was 1,008. We'll make this exactly 1,000. 999. Let's see, 996. And I think 992 will balance me out at 6,000. So it's kind of flat. It's fairly flat. Fairly flat. Flat, another way for flat is uniform. Uniform means everything is approximately the same. Which is why we call clothing that all looks, when people like military uniforms, they all look the same. So, you know, that's what uniform means in general. We apply it to different things. In data, it means the results. So in statistics, it's results. All look the same. Okay. So this occurs, you get distributions like this when you have things that have the same probability. These are common when the distribution of results is about the same for all of them, for all categories. Okay, we don't really see that often in statistics. When we're doing statistic problems, it does show up a lot in probability though. Rolling a single die, you should get numbers that are pretty close to each other. If we had exactly 1,000 on all of them, I would call bullshit. The odds of getting 1,000 even across all 6 categories is like almost next to none. Just random chance doesn't work that way. So there's slight variations, but they're all pretty close. So we see things like this when we're talking dice, a single die, which is for dice, suits and a deck of cards. We'll be doing stuff with cards later. I will show you a deck on the screen and discuss it when we get to it in chapter 5. But there are 4 suits. There's the heart, there's the diamond, there's the spade, and then there's the club that looks like a 3-leaf clover. There's 4 suits and there's exactly 13 cards of each. So they come up about the same amount of time, same frequency. Okay. And even though I'm going to do these graphs, these shapes are so important. I did them last Wednesday. I'm doing them today, and I'm going to do them this Wednesday too. I'm going to go over them again because it's kind of really important. Here I added the uniform, but I want to add what kind of categories have these stuff in. The next category we had was bell-shaped, where the data looked roughly like this. So here's like the mean, which we'll go over in a little while or on Wednesday. But these distributions, we use the word distribution to describe how the answers spread out across the range of possible answers. These are things that where like there's variation in life, like height, weight, IQ, things that just there's variation. We all have different heights. We all have different weights, but there's a general like average height. There's an average weight. Granted, the average weight in America is probably higher than many other countries. The average IQ, and we'll talk about IQ tests later on. And we haven't covered it yet, but this is kind of like the middle of the graph, middle of the hump. The mean and the median are both here. We haven't used either of those words yet, but I'm going to show them today. I showed them last Wednesday, and we'll do it again next Wednesday. That's our bell-shaped distribution. And those are the types of things in it. Skewed left. We have a hump, but the tail is longer on the left. So here is kind of like the middle of the hump, mid hump. And what you'll find here is that the mean, which we again haven't covered yet, is there, and the middle might be here, or the median might be there. The mean is always less than the median when you have these skewed left. Things like this are things that where it's unusual for something to have a low number, like GPA at graduation. Oops. My wife just shut my door because she's tired of listening to me lecture. GPA at graduation. Sure, there are a lot of students that have GPAs of 1 and lower than 2. They generally drop out of college before graduation because you can't graduate with you need a C in your classes, which is a 2.0. So there are GPAs that are lower, generally first semester, students that just didn't realize how hard college was going to be. But most of the time, GPAs are for graduating students like 2.5 to 4.0 or higher. Another thing that you see where this is skewed left is maybe age at time of death. Most people tend to live longer lives. Some people live really long lives. But then there are the unfortunate circumstances where babies are born and die in the first year, or a child dies young, and that's where there's results to the left, but most of the people die 50 and older. I hope that is not a conversation that triggers anybody. I hope you guys haven't lost a young one. But on to other things, let's talk about skewed right. Here, the hump is on the left. And the tail is longer on the right. Again, this is like the middle of the hump. And this is where you'll see the median is on the left and the mean is on the right. So the mean is, or median is less than mean. Again, haven't defined those yet, but we will. Where does this happen? Housing prices, things like this, where there's a bunch that are low, but not many that are high. Like if you look at housing prices in Visalia, or let's go with Visalia or Tulare, there are a lot of middle income homes. There's some that are pretty nice. There are just a few that are $1 million homes, but most are in the $200,000, $300,000, $400,000 range. And there are, of course, some that are left of the heap or the mound. Older apartments that are run down, or not apartments, but older homes that are run down with like 1 bedroom, they tend to sell for less. So housing prices is an example. Number of children in a family. Zero, 1, and 2 are fairly common, really common. 3's still semi-common. There are families with 7, 8, 9 children. One semester, I think I had a student that said they had 13 siblings. So those are like, there are people that have a lot of kids, but most people are like, oh, hell no, 1 or 2, that's it. I'm fucking done. These things are expensive. They're noisy. And while I love being a parent, I don't want any more. And that's why Mr. Jones doesn't have children. He's got friends that have children and he sees what they go through, and hell to the no. Housing prices, number of children, income is like this also. There's your middle income. There are people below middle income. And then you've got your, Jeff Bezos is over here, Elon Musk. they skew the results of income. Okay. Next thing we're going to look at, and last section for today, is we're just going to talk about graphical misrepresentations. And again, this is, you're not being tested on this, but like if you do this shit in the project, I'm going to be pretty disappointed. And so the easiest way to do this is see the lecture notes. And I'm about to show you because I uploaded them from the previous semester. Let me see where they started. I'll just hit share screen and do it now. Find it together. All right, so where did I put it? So each class has a file section. Okay, it starts on page 24 of the file section. Let me show you how to get there. Move this thing. Close. So if you click on files for your class and you scroll down, it should say Math 21 lecture notes. This will give you a general idea of what we're doing in each section, but I'm not actually following them. I've got good graphs in here though, and it's, rather than just trying to generate new ones, I'm going to go to page 24 and show you what I'm talking about. So, what can make a graph misleading? Let's take a look at this data set. Can I select it? No, it's PDF, my bad. So it says this following time series graph was created from the given historical data on life expectancy. What is misleading? So let's look at the data. 1950 was 68.2. 1960 was 69.7. 1970 is 70.8. These aren't that far apart, are they? 68.2, 69.7, 70.8. That's not that big of a difference. Even year 2000 only up to 77. So like the life expectancy grew like 9 years over 70 years. But if we look at the graph, it looks like 1950 is super low. And it doesn't really look like it increased by 9 units over 50 years. It looks like it's like multiplied by 10. And the reason why this happens is, can I annotate on this? I can't. There we go. Let's change. Oh, I got a touch screen on this, so gotta use my mouse. Okay, so looks like it's multiplied by 10. Oh, still trying to do it. This right here says 68. Oh, I know what I might be able to annotate with. Can I do it over here? No, it doesn't want to let me do it over there either. And up here is 78. And that's part of the problem. If the graph started at 0 and then had 68 up here, like way up there, and 78 wouldn't be much higher because of the scaling here, the graph would kind of go like this. So you wouldn't see that steep of a rise, and it doesn't look like it's getting like 10 times larger. So what's missing is this over here. Now, there is a way to do that to bring attention to it so it doesn't misrepresent the data. One way you can do it, and you kind of need to like do it by hand or know how to do like art real well. Jesus, I cannot draw a straight line with my mouse to save my life. So one way to deal with that, that's my attempt at a straight line. You kind of want to put like a little jagged thing in there like that. And then start like 68 and 70 and then go up to 78. that little jagged line calls attention to the bar, the graph. And then you can look at it and go, oh, it doesn't start at 0. It's still going to look steep as opposed to like the fairly flat line here, but at least it calls attention to the fact that the picture is a little misleading as it is. The lightning bolt kind of shows that we've cut out some information, the big stretch of blank area. So that's what I'm talking about, like misrepresenting data. I got a couple more examples we can do. I gotta turn off that scroll. There we go. So 3D graphs. 3D graphs, while they look neat, are fucking terrible. They are terrible. Why do I think they're terrible? Well, let's look at these things right here. Purple is 11 to 15. So it's 0.23. Let's see if I can do the drawing again. So 11 to 15 is right here. 0.23 is the purple. And 16 to 20, yellow is 16 to 20. That's right there. Red is 21 to 25. That one's right there. And this one in front, the 6 to 10, is right here. Now look at the values that associate with it. Maybe the 21 to 25 isn't that helpful to notice, but notice what happens with the other ones. 6 to 10 is 0.25. 0.25 for this one. 11 to 15 is 0.23. Does this one look just a little bigger than that one? Because it's only a little bit bigger. If we made that into percentages, it'd be like 100% and 92%. It's only a little tiny bit bigger. And yet this one looks much bigger. It's all a matter of perspective, the way they set up the 3D chart. Whatever's closest to you looks bigger. The 0.18 in the back, this is 0.18 back here. While 0.25 is a good bit bigger than 0.18, the yellow area is like super small. I hardly see any yellow. As opposed to, I see a lot more purple than I do yellow, and it's not, the relationship doesn't work. So 3D graphs are bad. They look cool, but they don't represent the data well. Okay. And another one to point, look at the 1 to 15, 1 to 5 is right there, it's green. This is 0.13. This one back here is 0.10. Wait, 16 to 20 is actually a good example of what we already have right there, the 0.13. The 0.13 from hours 1 to 5 has more color showing up than the 16 to 20 right there, which is a larger value. There is more green on my screen right there than there is yellow up there. So like it really kind of skews the way I perceive it. It can be very misleading, and oftentimes it's not done deliberately, but sometimes it is. Sometimes the results are presented to shed a favorable light on something to give it a bias, to make it look more important than it really is. So don't avoid 3D graphs if you can. And that's kind of it for that. It's good to label and title graphs correctly. This has got the hours, but like when we do it in StatCrunch, it might be helpful to not just have the hours in the table, but also the units, the relative frequency listed. when we do pie charts in StatCrunch, I'll click back over and do it. It will show, we can set it up where it shows the relative frequency next to the hours. So we're not just getting the group, well, you're also getting the data. So let's take a look at that. Oh wait, I want to still share screen, but I just need a different tab. So stop sharing that. We'll come back over here and look at the pie chart we got with the data. We'll do age and we'll, ooh. Do I want to do age? Let's see. This is gonna, it doesn't bin it. At least it shows it though. It shows the age, it shows the number of responses, and it shows the relative frequency as a percent, not an actual relative frequency, but as a percentage. I could do the same thing doing the frequencies over here. I can do, that was a graph with data. I can do a pie chart with summary, and I could tell if the categories are the midpoints and the counts are in the frequency. And let's see, I wanted to show count, and I do want it to, do I want it to show count? Yeah, I wanted to show count and then maybe percent of total. And so now it's showing me, it's got the midpoints listed. If it said, still said 0 to 10 and 10 to 20, that would look better for a pie chart. But here at least it shows them, and the widths are relative. It's no longer 3D. And it also shows the values with it. So there's good ways to represent stuff graphically, and then there's bad ways. Ideally, you will stick to good ways. Are there any questions? That's it for today's lecture. All right, on Wednesday, we will be doing 3.1. And we'll show you how to calculate mean, median, mode, how to do it in StatCrunch and by hand. You should know how to do it. They're fairly basic skills. And these you should be able to do by hand. And we'll talk a little bit more about when we want the mean, when we want the median, when we want the mode. And that will be it for that week. Other than that, we are all done.
Mr. Jones?
Yes, Gabe.
I just had a question. So if we do end up misrepresenting data on accident, will we still get like a 0 on a project we have, or?
No, you wouldn't get a 0. I might mark you down on it. And if you submit the project early or submit the graph, generally, some students, when we did the project one, when we're going to start the project, we'll be like starting chapter 9 or so.
Okay.
And I will have all the data for you. You're just going to be going through the project and answering questions. And so if you work early and get it done early, you'll be able to ask me like, hey, how does this look? What do you think? But I give you feedback beforehand.
Okay.
But it's not going to be a huge markdown. No.
Okay.
This is more important for when you get to the real world and because you will make, if you're doing any office work whatsoever, if you're indoors for any type of job, there's a good chance you're going to make a graph at some point.
Yeah.
And it's good to know, don't fuck it up. Don't be.
All right.
And the biggest thing is like, if you actually go into a field where you do it a lot, where you're like, if your job has a lot of statistics in it, even though you don't think it does. My friend's got a master's in archaeology, but he does a lot of work, does a lot of social work, and there's a lot of doing statistics on the population, different breakdowns of groups and stuff like that. And like you can misrepresent data pretty well. And if you're doing stuff that's trying to affect public opinion and shit like that, it's bad.
Okay.
So yeah. Any other questions? That was a good question.
No, I think I'm okay.
All right. I will catch you guys on the flip side then.
Thank you, Mr. Jones.
Uh-huh.
Have a good day.
You too.
Bye bye.
Good
See you
day.
later.